Okay, ladies and gentlemen, you are working on this. Get a good start on it. Work together with a partner. Okay? Kind of a continuation of yesterday's lesson about quadratics, their characteristics. Let's go through it together here. The parabola shows the path of your first golf shot, where x is a horizontal distance in yards, and y is the corresponding height. So we've got our first golf shot here. The path of your second shot is this function. So this is our second one. Which one travels farther before hitting ground, and which one travels higher? All right. So how many say shot 1 travels farther? How many say shot 2 travels farther? Okay. Well, how far does shot 1 travel? 100. All right. It goes a total distance of 100, right? So this is our first shot. It gets shot, travels 100 feet. Or 100 yards, excuse me. Yeah, it's not to scale in terms of the person. All right. Hey, shot 2. Shot 2 travels, you're saying 80?
Yeah.
You think so?
Yes.
No? Okay, well, before we do that, let's talk about the height here, because it's pretty easy to see in shot 1. How high? 25. Now, that represents our vertex, right? And a vertex when we're dealing with these is which letter? What do we call our vertex? H and K. Okay. Yeah, we can call it B, I guess, too. But we're referencing it as H and K. And when we're looking at vertex form, y equals a times x minus h quantity squared plus k. So in picture form, it's pretty easy to see the vertex. But then we go to equation 2. What's our vertex? The vertex, or HK, is 80. 80 what? 80 0? Are we sure? Okay, what mistake did I just make there that I think some of us made? Yeah. Yeah, I didn't distribute this, right? I mean, I've got to get the x squared first. I don't have it. Okay, so this isn't right. Okay, and that's an easy mistake because we look at it and we're like, oh yeah, vertex form, but it's not because there's no x squared right now. So we've got to multiply it in. So when we do that, we get f of x for our second shot is equal to negative 0.02x squared, and then plus what? 1.6 exactly? Okay. 1.6x. All right, now does that help us? I mean, I really still need to find the vertex. Can I do that using this? What do I have to do for that? What? Okay, everyone talk about it real quick. This is supposed to kind of summarize pretty much what we did yesterday. A lot of it. Let's go ahead and go through it. What do I have to do? Yep. Go ahead, Matt. Okay, and that's going to tell us our h term, right? Okay, and opposite of b is negative 1.6 divided by 2 times negative 0.02, which is 40, exactly. Okay, so that means our height, nope, not our height. Dude, that's only h. Well, that tells our halfway distance, which means our total distance is what? 80, okay. So if our halfway is 40, so if you model this golf shot, this next one, it's like that. Okay, we're right. That's a bad ending to the shot. Okay, hit a B or something. Okay, we're at 40. So that means this entire length, that's halfway, so this entire length from here to here is 80. All right? how do we find the height? So we know this. Yeah, you plug it back in. Okay, so we plug it in. We go, okay, f of x, am I still on the screen there? Yeah, f of x equals negative 0.02 40 squared plus 1.6 times 40 is 32. Those of you who said a number, that's ridiculous. 32. The height is 32 yards. All right. Which one goes further? Shot 1. Which one travels higher? Shot 2. Now, here's where you guys are going to be a little irritated because, dude, there's an easier way to do that than this. Does anyone know the easier way? Rory? Not really 80. Let me, go ahead, Sylvia.
Well, I know an easy way to find the total distance that it travels.
Okay.
Would be just to make y equals 0 and then find the x-intercepts.
Good. We could have just started with this equation. We could have said, well, let's make y equals 0. I mean, this is factored form right there. You love factored form. Factored form tells you your zeros. So if I say, okay, y is 0, that's going to tell me my x-intercepts, which means if I'm graphing it, right? Thank you. If I'm graphing it, but there's my shot. I should have an x-intercept right here. What is this x-intercept? 0. Let's hope one of these, either that or that is 0. Which one of those gives me an x-intercept of 0? Yeah, this one right here. Look, if I go negative 0.02 x equals 0, and I solve for x equals 0. If I say x minus 80 equals 0, and I solve for x equals 80. Look how much easier that was. That tells me this is 80. If it's in factored form, yeah. Because halfway, remember, halfway between your zeros on your x-axis is your vertex. Which means I know the halfway point is 40, which then I can use that back in here to solve for y. I didn't have to go through and find the vertex this way. I could have done it this way. Now, can you get there this way? Yeah, for sure. Okay, but you can get there this way a little faster. Like the example I used about Hagen's. You can drive out here and go straight to Hagen's, or you can go out to the freeway, go up to Marysville, come back around, and come back to Hagen's. You still get there. It just takes a little longer. Okay? So it takes a little longer, but you can make it doing it this way. This way is a little faster. You use a little more gas, like if you're going to Hagen. You can listen to some new music, like if you're driving, I guess. But in math, you got to practice your math. Like if you love number crunching, there you go. No perks, other than
you get it in standard form.
I guess, yeah. If you need standard form, you can use it. Yeah. All right. So then you plug it back in, the 40 back in. I'm not going to do that, but okay. Questions? All right. I don't want to spend any more time on that. Let me give you that real quick. Here's your what if. What if the graph of your third shot is a parabola through the origin that reaches its maximum height, 28 yards, when x is 45? Compare the distances it hits before, or hits the ground with the distance of the first two shots. Okay? That one should not take as long. In fact, it might be done within 30 seconds. You know what you're doing there. You guys will never look at golf the same way again. Those of you who watch golf, you're like, hey, look at that parabola. All right. My parabola is slicing into the woods. Okay. All right. 45 at 28. How far does it travel? Travels 90. Okay? Travels the second longest, right? Okay. Hey, we're going to be done with that. I want you to take out yesterday's assignment, please. talking about, so 15 and 16, we're talking about opening upwards and downwards. Here are solutions here. Okay, we know 15 is increasing. It's going upwards, but when I think of my parabola, since it's facing upwards, my parabola is actually decreasing when you got to find what your vertex is. So in this case, my h term is 0, right? So it's decreasing as x is less than 0. And then once x is greater than 0, it's increasing. So if this is the ordered pair 0, 2, I think, for this. Okay? So when you're describing your increase or decrease, it's decreasing when x is less than 0, increasing as x is greater than 0. Okay? Yeah.
On the decreasing and increasing, I put that it was decreasing on just the left side.
Okay. Yeah, so if you said, hey, it's decreasing on the left side, let's get a little more specific. And you can fix that right now. We didn't go into a great detail on that, but you need to know the vertex and be able to say it's decreasing till this point, and then it's increasing. Yeah. Kenzie? You drew a little picture and then described it?
Well, you had like the minimum, the domain, and the range, but then you drew a little picture of the graph, and you had like the little increase there and the little decrease there.
That's good, but I'd like you to get into mathese on it. Okay. Sam?
What if you did like a decrease? I don't know. I had my brother help me out, and he said to do like parentheses, negative, infinity, comma, 0, then a hard fraction.
Man, yeah, so you're doing some real math there. That's like some serious math. Do you know what that means?
Yeah.
Okay. So if you understand the math behind what you're writing, that's fine. Now, I'm not going to go into that math, okay, because well, maybe I'll hit on it just real quick. Give me your whole statement.
For decrease, I have parentheses, negative, infinity, comma, 0, hard fraction.
Okay, so you're saying negative infinity to 0, like that. Okay. You guys, hey, this is math language here. Okay, this is saying that my graph is increasing up through negative infinity, or excuse me, it's from negative infinity, it's going to 0, and then it's stopping there. Now, you actually, did you write it's increase or decreasing there? Okay. 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 So really, this is like saying x. And so this is another way of mathematically saying this statement. Okay? Hey, you guys understand that? Okay, maybe not that for a minute, but this is saying as x is x is greater than negative infinity and less than or equal to 0. Okay? So Sammy, you understand that? Okay. All right. You don't have to write it like that. You can just say good. That yes. Yeah, so it's saying x is decreasing when x is greater than negative infinity, but less than or equal to 0. Okay?
So you're saying like y is decreasing when x is this, right?
Yes, you're saying your y value. So your function is so f of x is decreasing. Okay? I don't expect you to write it like that right now. Sammy, that's good. If you can do that, that's awesome. If you guys know how, if that makes sense to you, then write it like that. I'm not going to go into that notation right now. Just too many other things we're going through. Emily. Uh-huh.
And then it's upward, it never hits x equals 0.
Right, but on your graph, so let me just sketch it really quick. X equals 0 is this line, right? So you understand? Okay. Good. Any other questions? So that graph hits right there. Okay? So once again, just to make sure everyone's clear on this notation, because I don't want you trying to do this on your quiz and not understand it. Because really, this is great if you can understand it. The graph is an f of x. No, it's a y. It would be a y. But I'm going to change it to f of x right now, just for the sake of what I'm doing. So I don't want to change all my f of x's. Okay. The graph f is decreasing. So the whole function is decreasing from negative infinity. That means it's from negative infinity on the x-axis all the way until you hit x equals 0. And then once you get to x equals 0, it's increasing again. So this statement just says, hey, I'm decreasing from negative infinity until I get to 0. If you were going to say increasing, you'd have to put another statement. Okay? You'd have to say the graph of f of x, is increasing. And you give it a shot. See if you can actually write down how you would write that in this format. See if you can do that. So let's go to this format first. So we would be starting at 0, and we'd be working to what? Infinity. And beyond, dude. Like Buzz Lightyear. Okay? Then we go x. And so if my graph is increasing, it starts at 0, and x is greater than or equal to 0, and less than infinity. Okay? So when we do that, if we write it in this format, we put our 0, we put our infinity, which that was a horrible infinity, but that's okay. Okay? This soft means no equal to. So on this side, would it be a hard or a soft? It'd be hard. And here it would be soft. Sammy, is that what you got? Glad you brought that up. That's awesome. Which way you do? No, it does not matter which way you do. Okay? But you've got to emphasize, if you're doing this format, you have to tell me. You could just say, for what we're doing, you could just say increasing that. I'd be fine with that. And you could say decreasing this. You do that, man, grading your test would be so much less reading for me. Awesome. But you don't have to do that at all. That's for sure. Okay. You guys are a little ahead of the game for next year now. I mean, serious. What math is your brother in? Calculus, BC, or stats. That's pretty cool, statistically speaking. Okay, one of the concerns I've had with some of our graphing is that you guys are, well, not you guys in general, but as a whole, some students are still turning in grids that they're like, hey, it's y equals x squared. So I'm going to tell you here in a minute, I want you to graph this one. X squared minus 4x plus 6. Okay? And I have some students doing this stuff. Oh, it's just x squared. All right, I know my vertex. And okay, good. Like that. And I'm not joking. That was turned into me yesterday. That is not a correct graph. It's a parabola. I don't know. I mean, maybe the vertex. Even if the vertex was in the right spot, you have got to have accurate points plotted. Okay. So if I'm graphing y equals x squared minus 4x plus 6, the first step, we need to make sure that we find the vertex. So everyone gets 30 seconds. Find that vertex. Best you can, 30 seconds. Okay, tell your neighbor what you got again. 2. Okay, so the vertex is 2, 2. Opposite of b over 2a is 2. Plug that in to your function and you get 2. 2, 2. How many got 2, 2? Okay, not the little dress thing. Okay, 1, 2, 1, 2. There's the vertex. We good? Okay. So from there, we are going to graph this using patterns. Okay, I'm not going to plug in values. If you want to, you can, but just so we're clear, the way you use patterns, over and up. When you go over 1, you are going up the square of that. So if we called this like, well, let's just say It's over 1. We're going up 1 squared times our a term. It just so happens when a is 1, it doesn't matter, right? Because we multiply by a and it's just 1 again. So we go over 1 and up 1. That's our next point. We go over 2 and up 2 squared times a. Well, a once again is 1, so 2 squared is just 4. Now we're doing this from the vertex, so we're going over. Here I should emphasize from the vertex each time. Over from your vertex. Dude, that was a massive pin that just rolled across the screen. That was scary. All right, so over 2 and up 4. Okay, over 3 and up 3 squared times a. 3 squared is 9 times a, just 9 still. Now, for those of you that do this on your test, and you're like, oh, well, hey, I'll just put another point up here. Okay, am I in the right spot? Yeah, quick. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, if you're going to put that point there, first make sure it looks accurate, and second, label it so that I know you're accurate. 3, 11. And then you have got a half a parabola. And then reflect across the axis of symmetry. And if we label that, that's x equals 2. Make sure you label it as x equals. Don't just say 2. And once again, I went off the graph. I better label it negative 111. Okay, now put your arrows on the end. Otherwise, your graph is called discrete. Did I make a mistake? Uh-oh. Yes. To the right of the, oh, it is 511. Thank you very much. My goodness. It's neat in this class, well, a lot of my classes this year, if I make a mistake, dude, hands go up like immediately. I just know, I made a mistake. I know, that's what I'm saying. They're like hands up immediately. It's like, I made a mistake. I know. Okay, good? Any questions on it? Okay, let's see if you really understand it. Let's graph this one. Y equals 2x squared minus 20x plus 41. Y equals 2x squared minus 20x plus 41. Okay? You have 45 seconds this time to find your vertex. A little bigger numbers. Alrighty. What do you guys have? 5, negative 9. There it is. 5, negative 9. So when we plug the 5 in, make sure you're not making this mistake. Hey guys, when you plug that 5 in, that is 2 times 5 squared. Square the 5 and then double. Not the other way around. Square the 5, 25, double. That's 50. Not 10 squared, which is 100. Okay? Otherwise, then you get positive 41. You're like, dude, it doesn't fit. Okay? All right. Good? 5, negative 9? All right. So 5, 1, 2, 3, 4, 5, negative 9er. There it is. Total woohoo. Okay? So there it is. So now, let's graph it. Okay, pause. Right back here. Focus up here. Focus up here. Otherwise, here you will be out of time again today. All right. We go over 1 and up. Yeah. Remember our pattern. We go over 1 and up 1 squared times a. So a this time is 2. So we got to double everything. Over 1 up 1, but we're doubling it. That's 2. Remember, that's our vertical stretch. Right? Over 2 and up. We got 8 there. Over 3 and up. 18. Holy moly. Did I go 3 there? Oh, man. All right. Over 3 and up 18. Good thing. I think that's right there. Oop, I'm over again. Too many dots. Sorry. Okay. Total fancy. What's that? X equals 5. Yep, it's a parabola on diet. All right. Put your arrows on the end. Good? Okay, hopefully I've cleared that up a bit. All right, you guys know what you're doing today.